Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to start off with a simple example which I think is going to motivate our next discussion. And here we go. We start off with having the Heaviside function h, which is defined by this over here. And this function is named after the electrical engineer Oliver Heaviside and is used to describe an electric current that is switched on at time t equals to 0. So first of all, you are asked to sketch the graph of the function above and then find the limit of this function as t approaches 0. So let's start off by sketching the vertical axis and the horizontal axis. Okay, so next is if you have t being less than 0, the value of this function is equal to 0. So we're going to denote this with open circle to indicate that it doesn't include point t equals to 0. Yep. So the graph is going to be in this line. Okay. Next, when t is greater than or equal to 0, the value of our function is equal to 1. So at point 1, this is this full circle and it goes in this direction. Okay, so there you go. That's the graph of the above function. And then we are going to find the limit of this function as t approaches 0. So t can approach 0 either from the right direction or the left direction. So if t comes from the left direction, you can see that the value of our function gets closer and closer to 0. Whereas when t approaches 0 from the right direction, the value of our function here will get closer and closer to the value of 1. So since the two values here are different, therefore the limit of our function as t approaches 0 actually doesn't exist. And this is just a simple example which leads us to formally define the idea of one-sided limits. Okay, so this is what I'm going to do next. I'm going to talk about one-sided limits. So if you can make the values of your function here arbitrarily close to L, which means as close to L as you like, by taking x to be sufficiently close to A, and here x is less than A, which means when you think about it, you are approaching A from the left direction. Okay, so this means that x is approaching A from the left direction, and because of that you can specifically write using this negative symbol here at the top, which is basically saying that x comes to A, or x approaches A from the left, and this is the limiting value of the function is equal to L. Okay, so this is the definition of left-hand limit. Okay, now similarly we can define the right-hand limit of this function, where you can say that the limiting value of the function when x comes from x comes to A from the right direction, so the result here is going to be equal to L. So the positive sign to indicate it comes from the right direction, whereas the negative sign here to indicate that x approaches A from the left direction. And in order for the limit to exist, so this is the definition of limit. So the limiting value of this function when x approaches A is equal to L will exist only if you have both limits, which is the left-hand limit and the right-hand limit, equal to the same number. Okay, now perhaps we can look at more examples to illustrate the discussion just now. Yep. Okay, in this example here, let us find for the first one here, what is the limiting value of this function when x approaches 2 from the left. So this is the point of interest. So x comes to 2 from the left direction. So based on this, you can see that the value of our function here will rise and it will get closer and closer to 3. So this answer for question A, the answer is equal to 3. Now, what is the limiting value of the function when x approaches 2 from the right direction? So from the right direction, you will see that the values of gx is going in this direction here. It's going downwards, and it will get closer and closer to the value of 1. Okay, so for B, the answer is going to be equal to 1. Now, C, what is the limit of this function when x approaches 2? So for this one, the answer is it doesn't exist. Why? Because the left hand limit and the right hand limit is not equal. Okay, next example here is, what is the limiting value of this function when x approaches 5 from the left? So this is the value of interest. So it comes to 5 from the left direction. So you can see that the value of our function here is rising, and it gets to this point, and then it jumps to this lower point here, and it continues the journey. And as it gets closer and closer to 5, we can see that the value of our function gets closer and closer to 2. So that is the answer here. This is equal to 2. And the next question is asking you to find the limiting value of this function when x approaches 5 from the right direction. So from the right direction, therefore we start off at this point, going in this direction, and as it gets closer and closer to 5, the value of gx gets closer and closer to 2. So the answer is going to be 2, and therefore for this one here, you can see that since the left hand limit and the right hand limit is equal, it gives the same number, therefore the limit of this function when x approaches 5 exists, and the value is equal to 2. Alright, that's all for now. Thank you very much for watching.